This is Jee Advanced 2020 held on 27 September, paper 2. Here there are 3 sections. In first section, there are 6 questions and the question is integer type. In section 2, if you see, there are once again 6 questions, and here the patterns are more than one correct and partial marking is there, although negative marking was also in section 1. In section 3, there is truncated values, round off figure for numerical values is also there, and there is no negative marking over here. So that is the good option for students as like in paper 1. So let's start to present the solution of paper 2 from section 1. In this video we will discuss only on section 1, and next coming video will be there for section 2 and section 3 also for paper 2. Let's start our video right after this short break. And if you are first time on my channel, then please subscribe and hit the bell icon button to get the video first. Jee Advanced 2020, paper 2. Here also there are 3 sections. In this video we will discuss about section 1, which is single digit integer, +3 for correct and -1 for wrong, means negative marking is there. So, and the integers are from 0 to 9 you have to fill. So let's start. There are 6 questions in this section. Question number 1. In this question number 1, this is from complex number. Question number 1, this is from complex number. The condition is given here somehow, means equation in Z, there's 4 degree, and you have to find the minimum possible value of Z1 minus Z2 whole square. Whereas Z1 minus Z1 comma Z2 belongs to S, real part of Z1 is positive and real part of Z2 is negative. So if you consider Z1 is equal to x1 plus iota y1 and Z2 what do you call x2 plus iota y2. So here what we say, let's say this is Z1. So Z1, that is x1 is positive, and here what we call means x2 is also negative according to this. Okay, so we have to find the minimum value of this. Later on we'll discuss about detail, but first of all analyze about this one, 4 degree identity. So that is z to the power 4 minus mod z to the power 4, that is given, let me write 4 iota z square. Here you see mod z whole square, we know the formula, mod z whole square, that is z bar z one can write. So using this result over here, that we say z to the power 4 minus mod z, z for mod z whole square you can write z bar z. So finally what we say here, this is whole square, and 4 iota, that is z square. Now dividing by z square, what we say here, z square, here it left, and left with over here, that what we say z square cancel, so bar z whole square you can write, and that is 4 iota. So for this 4 iota you manage like this. Before this, applying here this identity, square difference formula, that is z plus bar z, and here z minus bar z, and that what we call, if you divide here, then better just write 2, and here that is 2 iota, and here it becomes 1. So this will become, that is x, and this what we call y. So xy equal to 1. So this is the locus of hyperbola, this is what we call rectangular hyperbola. From here what we conclude, as x1 is positive, so y1 should be also positive, and here that what we call y2 should be also negative because on multiplication you have to find 1. Now what we have to do? We have to find this minimum value of z1 minus z2 whole square. So let's open it. As you know, z1 minus z2 mod whole square can be written as z1, that you can substitute over here z1 z2 over here, that what we say x1 plus iota y1, and then after minus x2 minus iota y2 over here, okay, and then mod whole square. So finally what we conclude, x1 minus x2 whole square and plus iota into y1 minus y2 whole square. So you just better just like this way, do like this way, whole square, and here that is will be also that it means, okay. So that is the square here, you know, as x plus iota y, collect this iota imaginary terms. So x1 minus x2 whole square, and here we say y1 minus y2. No need to write over here iota. Directly we write this one. So better just eliminate this iota over here. So what we recall that here that it will be y1 minus y2. Okay. Now open it. So when you while opening here, what do you say? X1 square plus x2 square minus 2x1 x2. You can write x1 x2, and here also once again you can write minus x1 x2, and that is plus y1 square plus y2 square, and once again minus y1 y2, and here that is minus y1 y2. How many terms are there? 1, 2, 3, 4, 5, 6, 7, 8. As you see over here that y1 y2 on the product of this y1 y2 is negative, and here this is minus sign, so negative into negative, that is positive. Here also that will be positive, here also this will be positive. While applying AM and GM inequality for maxima and minima, as this is the minimum possible values required over here, so if you add this all, so as you say x1 square, all this 8 terms, x2 square minus x1 x2, and here that we say minus x1 x2 minus y1 square plus y1 square plus y2 square minus y1 y2, mind this point, minus y1 y2 and minus x1 x2. These all terms will become here on the product, that is positive because the product is negative, and here finally, so that is 8 and greater equal to, on making the product here, always you find x1 y1 x2 y2, these all terms will become 1. So 1 to the power, what do you have to say, 1 by 8. So finally this result will be 1, and this entire result will be, this should be greater or equal to 8. So 8 will be here, so the answer will be 8. 8 is your final answer. Okay, one method you can go ahead from here also, xy equal to 1, rather than doing this if you are not getting idea how to tackle this AMGM over here. So you can plot this xy equal to 1 under these conditions, x1 positive and x2 positive. Let's see. Let me do some another method here. So go for another method. For second method, you see z1 is x1 plus iota y1. z1 that we say is, just open this for second method, z to the power 4 minus mod z to the power 4 iota z square. If you open here, then you can write like this way, z to the power 4 minus same, that is z bar z whole square. You can write for this mod z, and here you say 4 iota z square. Dividing this, what we call here z plus bar z by 2, into z minus bar z upon 2 iota. This much we have discussed as previous, and that is 1. So this is x into y equal to 1. So you have to now plot this as a graph. So if we draw the graph over here, let this be x-axis and this what we call y-axis. Okay, so here let's say x-axis. Okay, so this is, let's say, x-axis and this what we call y-axis. And if you draw the graph over here, uh, means axis, if x1 is considered as a positive, so and here to be considered this one xy become 1. So for real part of z1, that we say x1 is positive and x2 is negative. So it means it lies in either first or third quadrant. So the graph of rectangular hyperbola is like this one. So we have to consider the point, very point over here. So you have to consider this point, any of the point. Let's see. Um, Let me consider any point here. So if you consider this point over here, then you have to find the distance from this leaf, either from this leaf, either from any of the leaf. So where the leaf will find the minimum distance. So here you see, if you consider this, then the distance is much more. So here z1 minus z2 whole square, the minimum distance you have to find. So you have to find the distance here. The distance, possible distances, minimum distance is this much. So this distance you have to consider. So what will the distance over here? So these are the, this is vertex. This will be 1 comma 1 and this is minus 1 comma minus 1. So according to as per this, and the conditions also satisfy here. So simply this will be z1 and this will be z2. So you have to find the minimum distance. This will be the minimum distance of z1 minus z2. So let me write over here z1 minus z2 and this will be the minimum distance. So the minimum distance of z1 minus z2 mod minimum distance is given by the distance between 1 comma 1 and minus 1 comma minus 1. So of course the distance formula you can use this all, and that will be, the distance will be, that is under root of what we say 1 minus of minus 1, that is 1 whole square, and here that is also 1 minus of minus, that is once again 1 plus 1 whole square, and hence we say this is 4 and this is also 4, so that is 8 and this distance is root 8, but here it is asking z1 minus z2 whole square. So z1 minus z2 minimum distance whole square means you have to find the minimum distance of this, that is 8. So 8 will be the correct answer finally. Fine. So let's go for another question. Question number 2. So let's go through question number 2. This is from probability. The probability that a missile hits a target successfully is 0.75. In order to destroy the target completely, at least 3 successful hits are required. The minimum number of missiles that have to be fired so that the probability completely destroying the target is not less than 0.95. This you have to find. So what we see over here, let you can assume over here that n missiles be fired. N missile be fired for this target. Okay, so what do you have to find? We have to find the probability that target is destroyed. Our target is to destroy. Target is destroyed. Okay, so probability that target is destroyed is 1 minus probability that no hit is there. Because when it will hit, then only target will destroy. So if no hit is there, and here the condition is there, at least 3 successful hits are required. So means probability, what you have to eliminate over here. So probability one hit, one hit also you have to eliminate, and probability exactly 2 hits also you have to eliminate. So you have to, how to, one is the total probability, and that is from this you have to, means at least word is there. Here there is the word at least. For at least, whenever there is at least here, a total minus probability no hits, one hits and 2 hits. As 3 hits are required for at least case. In wherever there is at least case, you have to do like this way. So in this way, the counting will be less rather than doing tedious work. So what do you say here that it will be? Let's solve. Now here this is a binomial distribution as for successful hits, that is 0.75, that it means that is, this is nothing, it is 3 by 4 you can write here, and probability it's a successful means it hits, and it won't hit, then that is 1 by 4. So NCR you have to apply this type of work. So that is let's start 1 minus probability no hit. No hit is there means 1 by 4 to the whole power n. Means in all n missiles there is no hitting is there, means every hitting has the probability 1 by 4 over that. And now for probability that is 1 hit is there, so you see for means exactly 1 hit is there, so that it means from n any 1 hit is there, exactly 1, so that will be 3 by 4 to the power, you have to say as n. So 3 by 4 to the power means um, and exactly that is 1, and then after rest of the 1 by 4 you have to say n minus 1. Later on 4 will become as n, we will make the calculation later. And now first we apply binomial distribution. NC2, among this exactly 2 hits is there, so for this exactly 2 hit is there, you have to say 3 by 4 whole square and 1 by 4 to the whole power, that is n minus 2 you have to write. Okay, fine. So go ahead for working this. As you know, here probability this target is destroyed, this is not less than 0.95, that much you have to solve. So means 95, not less than 95 means should be this result, this entire result is not less than 90, means this entire result is greater than, so 0.95 this will be. So let me make here 1 minus, let me write once again, 1 minus 1 by 4 to the power n you can say over here, and later on we say minus nc1, you can solve this also. Let me write first nc1, and here that will be 3 by 4 to the power n, because 4 power n minus 1 is there, and then after minus nc2, and here 3 square and 4 to the power once again n is there, was 3 square, and here completing this 4 to the power n, and this all should be greater or equal to, according to this, 0.95. So for this you have to write 95 by 100. Now transpose this one over here, so that it means this implies what we say here 1 by 20. So what we say here, this is greater or equal to, and transpose this all left side. So what we recall that 1, and solving this we will get 3n plus here 9 n into n minus 1, that will be 2, for that factorial 2, and this entire upon 4 to the power n. Now solving this, what we recall here, if you solve this inequality, so here the space is not there, let me write over here. So this implies, this entire result implies over here, so let me write here, that is, this implies 4 to the power n is greater or equal to cross multiply, and that what we call multiplying 20 with here, that will be 20, and then 3, that is 60n, and then after plus 90 n into n minus 1. Now you have to find the values of n, minimum value of n, which satisfies this inequality. So if you see, let's see test about over here. So let me test some for n equal to 5. If we write for n equal to 5, just make a hit here. So LHS become here, LHS portion will become, that is 5 when you put over here. So that will be 1024. You all know well, 2 to the power 10, that is 1024. And here, and RHS is, that is 20, and then 5, 6, 30, 300, and then after what you have to write, 90, 5, 514, 49, 36, and 5, that is 180, and 0, 1800. Okay, so RHS will become here 1800, 300. It's not possible, it's going beyond. Now let's see. So this will be not greater than LHS, not greater than here. So now just for n equal to 6, if you go for n equal to 6 over here, so let's see LHS. What is LHS over here? That will be 4096. Okay, and what about RHS? That is RHS is here, you say that is 20 still, and when you put 60 means that is 36, that is 360, and then after plus, let me erase this part, and here then what we say 360 plus, and that was what we call 90 times of n minus 1. So that means when you put here 6, 5, 30, 3, 9, 27. So that is 2700. And finally, what we get here, this is 4096, 2700, 360, and 20. Of course, hence for n is greater or equal to 6. Therefore, this implies that for n is greater or equal to 6, we can say that probability is greater or equal to 0.95. 0.95. So the minimum value is, therefore, the minimum value of n is, you see, 6. 6 is the minimum possible value of n, or minimum value of n, that is 6. So answer will be 6 of second question. Okay. So let's go ahead for third question. Question number 3. Let O be the center of the circle x square plus y square is equal to r square, where r is greater than root 5 by 2. Suppose PQ is the chord of this circle, and the equation of the line passing through point PQ is 2x plus 4y equal to 5. So first of all, draw the circle over here. Let's draw the circle. Let's draw a line, that is PQ. Here. Let's say this is PQ, the chord. Here the chord is P and Q. The equation is given over here. That is 2x plus, that what we call 2x plus 4y equal to 5. This one is here, the equation of the chord. Okay. Now you know here it is given that if the center of the circumcircle of the triangle OPQ, O is the center of the circle. So find this point, let this be O here, let this be O. So, and now join this O point with somehow just and mark this point O somewhere here, which is the center of the circle. And now mark this with, join this O point with P and Q point. So join this O point with this point P and this point for this Q. So you see here, circumcenter of the triangle OPQ lies circumcenter of this triangle. So if you consider over here, that is some point, that is R, say, let's say this is R, and let's set coordinate is here, that is x1, y1. So if we join these lines, if we join these points P and Q with this R, then we will find the pair of tangents, and with respect to this point R, that will be the chord of contact, this red line. And in this way, we can find the circumcenter, that will the this one midpoint of O and R will be the circumcenter. So what we say here, let's join this point first. So joining this point, what we call here, let's say this is R. So join this point with this P and this point R with this Q. This is the pair of tangent, and here let's say this point is, as you know, this is 0, 0, which is the center of the circle, and the equation of chord of contact, let me write equation of chord of contact, PQ. If you get the idea of chord of contact, this problem becomes too easy. That is T equal to 0. With respect to this x1, what we say, the equation of chord of contact, x1 plus y1 equal to, you say, this is r square, and this is the same line. So compare with this equation 1 and with this same equation, this one, 2x plus 4y equal to 5. This is the chord of contact, that one. So comparing what we with this line, 2x plus 4y equal to 5, what we say here, that compare and write down over here, x1 upon, you can say 2, y1 upon, you can say 4 over here, and then r square upon 5. So in this way we can get the value of x1, y1. So x1 will be, that is here you can say, that is 2r square by 5, and here that what we say, 4r square by 5. So this point and this point. As you know, now circumcenter, here it is given circumcenter of the triangle OPQ. Circumcenter of the triangle OPQ lies on this line. So as you know, that the circumcenter of this triangle, this is the property of chord of contact, you have studied already. We study the properties of chord of contact, that circumcircle, if we draw the circle over here, as this is right angle, this is right angle. So this point O, P, Q and R are concyclic, you can say. So here what we say, that will the center of this circumcircle OPQR is the midpoint of the line, because as this is right angle, and if points O, P, R, Q, means O, Q, P, R, P points are concyclic, so you can draw a circle over here, and as you know that in semicircle, that is right angle, semicircle angle subtended right angle, so here this is the midpoint of the center of the circle. So center of the circle will be the midpoint of O and R finally. So what we say, now circumcenter, therefore circumcenter we can write, circumcenter will be here, what we say, half of this, because 0, 0 is there. So that is simply r square by 5, and that is 2r square by 5. Okay. Now this circumcenter, according to as per question, it lies on x plus 2y equal to 5, 4. So this satisfies. So this circumcenter satisfies this line. So as it lies on this line, so satisfy here r square by 4, 5 plus 2r square by 5 equal to 4. This is coming from here, this line. If you satisfy this point on this line, this satisfies this point on this line here, that what we call, we can get here, that is not 2, that is 4r square. So let me check this. This is, so that is this one is 4r square, you see, and here that will be 4r square, 2r square, 2r square, 2 to 4, 2r square, and this is 2 times, so that is 4r square by 5. So finally, what we conclude over here, adding this, we find 5r square by 5, so that is r square by is equal to 4, and hence we say r equal to plus minus 2, that is 2. So radius is 2 over here. So the final answer will be, that is 2. So the answer is this one, as the integer type question was there, you have to write 2. 2 is your final answer. Okay, so this was the question 3. By using geometry also, you can handle this radius of this circle using 10th class geometry. So you can go ahead further we'll discuss in detail. Anyhow, come to the question number 4. Next question. The trace of the square matrix is defined to the sum of its diagonal sign entries if A is 2 into 2 matrix such that the trace of A is 3. Okay. So the trace of A cube is minus 18, and the value of the determinant is A and B. So let you can say this. That capital A equal to, you can assume a matrix as it is 2 by 2 matrix. So 2 into 2 order matrix. Here you have to assume as A, here B. Let's say this is C, and as the trace is 3, so the sum of these 2 entries are 3. You can write over here 3 minus A. Fine. So what is determinant of A? Determinant of A is, if you open this, and what do we say here? 3A, right? And then after minus A square minus BC. Okay. So if we have to solve A cube, so that what we call A cube, how to solve A cube, as A cube can be handled like this way. This one, A square. First of all, you have to solve this A square and then A multiply with this A. So A square you can calculate over here. That is A square plus you can say BC, right? And then after B, that is 3B, and here that is 3C, and that is BC plus 3 minus A whole square. This is A square matrix, and when you multiply with A, you will get A cube. So that is A, B, C, and here you can write 3 minus A in this matrix. So that is finally A cube will be written as A cube multiply with this element, with this row into this column, corresponding elements, A cube plus, let me write ABC plus 3BC, and here that what we call A square B plus B square C. Okay, this is actually 1, 2 element, so first row and second column, so that is plus you say 9 b minus 3 ab. Okay, so go ahead like this. And another element, that is 3ac plus bc cube, bc square, bc square, correct? And then after plus c times of, that is 3 minus a whole square. Although it's a very tedious task of calculating this all, so you can go ahead with having more patience. ABC plus 3 minus a plus 3 minus a whole cube. Okay, so as you know, that is trace of a. So trace of a whole cube, that is sum of these two terms, leading diagonal. So the leading diagonal, that is a cube, this one, ABC related with this ABC, and 3BC, and then after 3 minus a whole cube. So you have to find from here, that is, it means after you have to multiply with this term. So finally, what we say? Okay, 6BC, ABC, this ABC, 3BC, this ABC. ABC and ABC are related, and this is 18. So finally, what we say? Let me write a cube plus 9 times of BC. Okay, 3BC plus 6BC, that is 9BC, ABC related, and only the term left now, plus 3 minus a whole cube. Okay, and this is given, that is minus 18. Now equate this with minus 18, and here now solve it. So what we conclude, that BC, that is plus a square. Okay, so minus 3a, open the wall, minus 3a plus 3, and finally what we get? Minus 2 cube, because a cube term will be related later on. And after solving that, what we conclude over here, that is, means some can write like this way also, 3a minus bc. Okay, 3, 2, that is 5. So bc, and here you can say minus a square, and here you can say this is 5. So finally 3a minus bc minus a square, that is 5, and that is here, this is mod a. If you see here, this is mod a. This is mod a, whatever we have already solved, and that was 5. So finally, what we conclude over here, that is mod a equal to 5. This value is 5. Okay, so the answer will be 5. That's our answer. Question number 5. It is given here f domain is -1 to +1. G is also the domain same. Here real number, here that is -1 to +1. Okay, and form of x, that is f of gx, is defined over here. Now you have to test that, suppose C is the number of points in the interval this at which fog is not continuous, and D is the number of points in the interval this fog is not differentiable, then the value of C plus T. This question is blend of continuity and differentiability concept. So they are asking the mixed concepts in the same platform on the same question. So let's see, first of all, go for fog. Let's say fog of x, that is, this is fraction part of x, you can say. This you can say, this is x minus j is the fraction part of x. You better just write fraction part of x over here for fog of x, that it will be mod of 2 fraction part of x minus 1 mod, and plus 2 times of fraction part of x plus 1 entire mod. Okay, so now redefine this function once as The domain is -1 to +1. From -1 to +1, where the definition changes. So if you see here, where these terms are going to be 0 for due to differentiability, if you make it 0, that is the critical point. So that is x equal to 1 by 2. So for x, and also that will be the -1 by 2 from here. So from -1 to +1, you see -1, -1 by 2, 0, and +1 by 2 are the points where the function takes breaks. So means changes its definition. So we write x lies between -1 to, you write -1 by 2 you write. So you just record this relation between -1 to -1 by 2. How to tackle this? This will be here, you can see the value will be 2, correct? So x lies between -1 by 2 to 0. So here that it will be 4x plus 4, okay? And for the value for which x is greater or equal to 0, you know, and that is here you can make it greater or equal to -1 by 2, and that is -1, that is open interval is that. So x is greater or equal to 0 and less than 1 by 2. So it will be 1x again 2, and x is greater or equal to 1 by 2 and less than 1, you know, this is 4x. So these are the points where function changes its definition like this way. So it's from here, but it's very obvious. It is discontinuous at x equal to 0. At x equal to 0, you can see over here 0 minus h, that is 4. 0 plus h, that is 2. So discontinuous point. So C is the point. Let's see, it's asking here. Suppose C is the number of points in the interval. So there is one point at x equal to, it is, let me write here, it is discontinuous at x equal to 0. So C will be 1. Why 1? Because only one point where the function is discontinuous, and where it is non-derivable, it is non-derivable. At, you see, of course, as it is discontinuous, so it is not derivable at x equal to 0 also, and wherever there is a plus minus 1 by 2 here, if you check the differential here, the slope is 4, here the slope will be 0. So minus 1 by 2 and plus 1 by 2. So 0 and plus minus 1 by 2. 0 and plus minus 1 by 2. So total 3 number of points are there. So D will be 3. D is the number of points where the function is not differentiable. So finally the result of that is C plus D they are asking. So C plus D, the value is 4, and the answer is, final answer is, that is 4. So you can write here 4, that's your answer. And this is the final question. Now limit x tends to pi by 2, 4 root 2 sine 3x plus sine x. Here you apply CD formula and then go ahead. If you check over here for pi by 2, then you will find that is indeterminate form. So apply directly CD formula to reduce this entire material. Let me write limit x tends to pi by 2, that we call 4 root 2. 4 root 2. For sin c plus sin d, 2 sin c plus d by 2 cos c minus d by 2, that is 2 sin 4x by 2, that is 2x, and here you will get cos x. Now in denominator, if you see 2 sin a sin b, cos a minus b minus cos a plus b, so for this you write cos x by 2 minus that will be cos 7x by 2 here you can get. Later on, what we say, cos 5x by 2 is also there, copied out. and then you recall this minus cos 3x by 2 to associate with cos, and other terms, that is this one left, you can take out negative root 2 common over here, and we say 1 plus cos 2x, and in this way we can get limit x tends to pi by 2, and we say 16 times of 4 is 2, 8, and you say here that is 16 times of root 2 for 2 sin x plus x, root 4 you will get, and here that we say cos square x, right, into sin x. If you split this sin 2x as 2 sin x plus x, this 2 will associate with this 4, 4 16. And here what we get here, apply CD formula once again, that is 2 cos of 3x by 2, okay, and then we say cos x minus 2 cos 5x by 2, okay, into that we say cos c plus cos d. We have to apply here this first and third and second and fourth. Then after what we say cos 5x by 2, and then minus into that is cos x, and finally what we get minus root 2, and here also that is 2, so we can say 2 cos square, half argument formula we are applying here, 2 cos square x, okay. So finally what we conclude over here, that is limit x tends to pi by 2, that is you can solve over here, that is somehow 16 root 2 sin x, you can retaliate this cos x here, because here also you get cos x, here also, and here also get cos x, take out cos x common and cancel with this, so you can take out cos square x common also. So finally, because later on you can apply this formula as here with 2 cos A cos B. Let me write this. One more step will be required over here. So let me write cos square x properly, so that you can take out 2 cos x common. So one of the cos x will cancel over here, and here that is 2. Then apply cos c minus cos d. Then you say sin c cos c minus cos d, that is 2 sin c plus d by 2, sin d minus c by 2, that is so 2 sin 2x, and here what we will get sin, that is x by 2, and that is minus 2 root 2, and you just copy out here. This one is cos square x, okay. So finally what we conclude over here, limit x tends, let me write over here, that is equal to limit x tends to pi by 2, and this one 16 to cos x by 2 after iteration, that what we get here 16 root 2, and that is sin x somehow upon 8, that will be for this you can write 2 sin x cos x, so 4 to 8, 8, so 8 sin x, and then after sin x by 2 minus 2 root 2 will be left over here, because 2 cos square x you can take out common, so it's okay, cos square x will be retaliated. So finally substituting pi by 2 over here, you will get 16 times of root 2 upon 4 root 2, okay. Substituting the value pi by 2 here, pi by 4, that is 1 by root 2, and pi by 2 that will be 1, so 4 root 2 will be there, and minus you say 2 root 2. So finally what we get here, that is root 2 cancel out, 4 minus 2 2, that is final answer is 8. So final answer is 8 0.